Okay, hi guys. So the first thing we're going to talk about for this set of videos is, since we are doing systems of equations, we're going to talk about graphing. This worksheet was obviously found on my website. I used Lakuta software to make this worksheet, but with that being said, let's go ahead and do some graphing. And let me remind you that if you have y equals negative 3x plus 4, then your m here is negative 3 over 1, and your b here is positive 4. So what does that mean? Well, this is negative, so that means we're going down, and we always move to the right, unless you want to go left and go the opposite on the negative. But with that being said, let's go to our first point, which is b equals 4, which would be the y-intercept b is 4. Okay, so I'm obviously graphing up here right now. And we're going to go down 3, 1, 2, 3, and over 1. So we put a point there. And since I have a ruler, I might as well try and use it, because it might help us see this a little better. But we go and graph that, and that is taken care of. Okay, then for the next one, we have y is equal to 3x minus 2. So here m is positive 3 over 1, so this is positive, so it's up, right one, and b is negative 2. So our y-intercept here, I'm going to do this one in blue, is negative 2, so we go to negative 2 and put our dot. Then we go up 3, 1, 2, 3 over 1, and we have a point there, and we can clearly see where these intersect, which won't always be the case, but in this case it is. So we go ahead and draw the line. And what point is that? That is this point right here at 1, 1. So that would be your answer for this. That is what solves the system. So there are many points that work for each line. Actually, there are infinitely many points that work for each line, but there's only one point where these two lines meet, and that's right there at the point 1, 1. If you don't believe it, just plug 1 into 1, 1 into those, and you'll see that 1 is equal to negative 3 plus 4, and 1 is equal to 3 minus 2. So that's the first one. Let's do another example. Let's do the next one. We have x plus 2. Y equals x plus 2. So m here is 1 over 1, so up 1 over 1. Notice I'm always going right when I do this. And then b is positive 2, so we go to positive 2, we put our dot. And we go up 1 over 1, up 1 over 1. And I'm just going to go ahead and draw it without the ruler this time. Did my best. And then x equals negative 3. So where does that happen? Well, that's kind of harder to see, right? Let's look at a pie chart, or I'm sorry, a t-table. So if x is negative 3, what can y equal? How about 0? Yeah, that should be a point, because y has no bearance on what x is. So long as x is negative 3, we're good. Let's say negative 3. How about 1? So let's plot these 2 points and see how it looks. So negative 3, 1 is going to be 1, 2, 3. Sorry, it's going to be negative 3, 1, and negative 3, 0 will be right here. And so you guys can see straight up and down. And it looks like it's going to intersect about right there, which is the point negative 3, negative 1. But obviously you want to check that. So if we plug negative 3, negative 1 into this one, the top one, we have negative 1 is equal to negative 3 plus 2. Is that true? And so yes, because negative 1 is equal to negative 1. And then if we plug negative 3, negative 1 in for x equals negative 3, then we have negative 3 equals negative 3. There's nowhere to plug y. So that works. So the point negative 3, 1, negative 1 must be the correct one. All right, so that's just it for graphing. Graphing obviously has its pitfalls, like you've seen on the last example I just did. I wasn't exactly sure because my line wasn't straight. If I had used a ruler, it might have been easier to see, but it won't always be so obvious where they meet. What if it meets at 1/2? How would you know it was 1/2 and not maybe 5/8 or something? And so that's one of the downfalls of that. So that's why we learn other methods such as substitution, which we'll be doing in the next video. Thank you guys.